So it says corporate or mutual bonds usually make semi-annual simple interest payments. With a zero compound bond, there are no interest payments during the life of the bond, meaning the investor receives a single payment when the bond matures, consisting of the original investment and the interest compounded semi-annual. So this guy right here is telling us that this is going to be treated by compound. Even though it's treated as simple interest, you still have to use compound on it. That is, has earned. Zero compound are sold at a discount from their face value, and the buyer receives the face value of the bond when it matures. So let's see this problem. It says Doug bought a 15. So there we go. Time on this one is 15 immediately. Year zero compound bond paying 4.5 interest. So my rate on this one is 0.045. Compounded semi-annual. So my M is equal to 2. 4. So that's my present value, $12,824 with 50 cents. What is the face value, which is future value? So I have future value equals 12,824 with 50 cents times 1 plus my rate, which was 0.045 over semi-annual, so that's a 2, and then 2 times 15. If you don't remember where I got those, why I arranged those like that, remember that the formula for compound is future value equals present value, 1 plus rate over compound to the power of compounded times time. So we put that into the calculator. We have 0.045 divided by 2 plus 1 to the power of 30 times 12,824.50. So we have that our future value is 24,999.996, which this one goes up, or you round it up to, future value is equal to $25,000. It was rounded up because of that guy right there. Okay. What is inflation? Well, the technical terms is inflation in economics is a sustained increase in the general price level in an economy. To be more exact to me, I like more of this. Inflation means an increase in the cost of living as the price of goods and services rise. Okay? So now that we have the definitions, let's see how we can treat with this problem. It says, suppose that the inflation rate is 3.5%. So we know that the rate immediately is 0.035, which means that the overall level price is rising by 3.5 per year. How many years will it take for the overall level of prices to double? Well, they're not giving us that much information, is it? It told us how many times it's going to be compounded. It says 1 because rising a year. So that's 1. But we're still missing present value, future value, and time. Well, that's how many years? That's the question. And in this one, this is where you have to do a little bit of thinking. For this one, I'm going to put as a present value of 1. And since we're doubling, what's the double of 1? Well, 2. Okay, so that's our question. So let's answer this. Remember, the formula is future value equals present value, 1 plus R over M to the MT. So I have 2, which is my future value, equals 1 times 1 plus 0.035 over 1 and 1 times T. This is 2 equals 1.035 to the power of T. Now, how can I solve for T? Well, this is where we get logs. We're just going to add logs. So ln of 2 is equal to ln of 1.035 T. Now, because of the properties of logs, I can send this to the front. So I have the natural log of 2 equals T times the natural log of 1.035. So now I have natural log of 2 is equal to T times natural log of 1.035. The T and the natural log of 1.035 are multiplying. So let's divide by natural log of 1.035 to both sides. So I have that T is equal to whatever that is, which is natural log of 2 over natural log of 1.035. So we put that into the calculator. So natural log of 2 divided by natural log of 1.035. So that means that time is equal to 21.035, which since this is per year, we have to go to the next year. So it's 22 years. Why am I going to the next year? Because, again, this is per year, and this is still using that part of that 22 years. So we have to go through the whole thing. So it would take 22 years for the economy to double in prices. So you have effective annual percent rate. So it says if you invest $100 at 9% compounded monthly, and we use the formula, we get to 109 with 38 cents. And this investment, we would make $9.38 in interest, which is 9.38% of the original 100. Or we could say that $100 invested at 9.3 annually will produce the same amount as of interest as 9% compounded monthly. This makes the 9% the nominal or stated rate, while 9.38 is called the effective or annual percentage yield. Effective rate or annual percentage yield, the APYRE, is a simple interest rate needed to produce the same amount of interest in 1 year as the nominal rate does with the frequently compounded over 1 year. So, what do we have to get from all of this? So we have let's read the example. It's better to do this one by example. So it says the nominal rate is denominated as R and APY effective rate is denominated as RE. Okay? So we have, in July 2016, American Express offered its customer a money market savings account at a rate of 0.9%. So we have a rate. Rate equals 0.009. Assume that the compounded interest is daily, so that means that M is equal to 365. And the principal, so that's my present value, is equal to 100,000. Find the APY. So this here means that we must have the following. $100 at RE is equal to 100,000 at 0.90%. Okay? So pretty much we're going to use, and also it states that, where is it? Simple interest rate needed to produce the same amount of interest in 1 year and compound it. So there we go. And because of that definition that we have there, that means that we have time is 1. So how are we going to do this one? This is pretty actually interesting. We're going to use both formulas. So remember, simple future value equals present value. 1 plus RT is for simple interest. And future value equals present value. 1 plus R over M to the MT is compound interest. And we're going to be using them both, equal them to each other. So we have 100,000. 1 plus RE is equal to 100,000. 1 plus 0.009 over 365. 1 times 365. And we're supposed to solve for RE. So I'm going to divide by 100,000. What I do to one side, I must do to the other. So this goes over with this. And this goes over with this. So now I'm 1 plus RE is equal to 1 plus 0.009 over 365 to the power of 365. Okay? So minus 1 to both sides. So RE is equal to 1 plus 0.009 over 365 to the power of 365, all minus 1. So let's do the math for this thing. So RE is equal to 0.009 divided by 365 plus 1 to the power of 365 minus 1. So RE is 0.00904. 1. So the effective rate, or APY, this is the annual percent yield is the amount of money or interest you can earn on a bank account over 1 year. So we have, it's the same thing. So when interest rates are low, as they were when this tax went to press, the interest rate and the APY are significantly different. To see when the difference is more pronounced, we will find the APY for each of the given money market checking accounts, which were advertised in October 2008 when offered rates were higher. Okay, so again, the formula, it's right there. Let's write it again. It's RE is equal to 1 plus R over M to the M minus 1. So it says M, this is compounded monthly, so that's a 12. Our rate is 0.0335, and time is 1, which we don't need, but that's fine. So let's put this into the calculator. We have RE is equal to 1 plus 0.0335 over 12. 12 minus 1. So we put that into the calculator. We get 0.0335 divided by 12 plus 1 to the power of 12 minus 1. So, therefore, the APY is, this is approximately 0.034, is 3%. So let's do this one again using the same formula. So I have RE is equal, that's what I'm looking, rate is 0.023, compounded daily, so that's M equals 365. So I have RE is equal to 1 plus 0.0233 divided by 365 to the power of 365 minus 1. So 0.0233 divided by 365 plus 1 to the power of 365 minus 1. So that's approximately RE. It's approximately 0.0236. That means that the APY is approximately 2.36%. So it says Bank A offers a 3-year money market account with a rate of 1.80% compounded annually. Bank B offers similar amount money market account with a rate of 1.77 compounded quarterly. Bank C offers 1.75 compounded monthly. Which bank offers the highest APY? Or in short, which one's the best one to use to handle our money? So we have Bank A, and that's going to give me rate equals of 0.018. Compounded annually, that's going to give me a 1. Remember that the formula is for APY is 1 plus R over M to the power of M minus 1. So I have RE equals 1 plus 0.018 over 1 minus 1, like that. So I have 1.018 minus 1. Which this equals to 0.0, which is in percent APY is equal to 1.8%. So that's how much you would get in a year. 1.8% of your initial investment. Now, Bank B has a rate of 1.77, but this one's compounded quarterly, so this is a 4. So I have RE equals 1 plus 0.0177 over 4. 4 minus 1. We get that into the calculator. We have 0.0177 divided by 4 plus 1 to the power of 4 minus 1. So this is approximately 0.0178. So that means that the APY for this bank is approximately 1.78%. Now let's see what Bank C has to offer. They have a rate of 1.0175. This is M equals 12. So I have RE is equal to 1 plus 0.0175 over 12. 12 minus 1. So 0.0175 divided by 12 plus 1 to the power of 12 minus 1. So this means that the APY for this bank, it's approximately 0.0176. Which is 1.76%. So which one's offering the highest APY? The winner for this would be Bank A. Highest APY. Now, since this involves a little bit of algebra, they can give you problems to solve, not just future value. You could also want present value, or like the one we did in class where we were asking how long it would take to become a millionaire, remember? So let's do one to solve for present value. So again, we have future value equals present value, 1 plus R over M to the power of M times T. And this is telling me that Keisha Jones must pay a lump sum of, so that means that's future value because that's what she's going to pay in the future. And it says present value. That's what we're looking because what amount deposited. Rate on this one is 0.062. And time on this one is 5 years. Compounded annually, that means that this is a 1. So we have $6,000 because that's my future value. I'm looking for present value. 1 plus 0.062 over, I forgot to write the rate. I know, there it is. 1.6 over 1 to the power of 1 times 5. So I have 6,000 equals present value 0.062 divided by 1 plus 1. So that's 1.062 to the power of 5 So I have 6,000 equals present value 1.350898078. Divide that by both sides. What do you do to one side? You must do to the other. So I have that present value equals 4,441.49. Now, here we have the formula if you want to memorize it. But again, I don't like doing that because that's a lot of memorization. And it's just pretty much the same formula. The only one you need to learn besides the future value interest, compound interest, and simple interest would be the APY. And that's about it. So there's no need to have so many formulas memorized. But if you want to, at the end of this lecture, I will leave a couple of seconds so you can copy all the formulas which are on the bottom. Okay? So this one, it says a zero coupon bond with a face value of $15,000 will mature in 9 years. What is a fair price to pay for the bond today? So that's for today. We're still going to use present value. So that means my future value is 15,000. Time would be 9 years. Compounded how many times? Semi-annual, so that's 2. And my rate is 0.06. So I have 15,000 equals present value 1 plus 0.06 over 2. 2 times 9. So that's 15,000 equals present value 0.06 divided by 2 plus 1. That's 1.03 to the power of 18. So I have 15,000 equals present value times 1.702433061. Now we divide, and once you divide, you will get $8,810 with 92 cents. And it says the average annual inflation rate of the year 2012 to 2014 was 1.72. How much did an item that sells at 1,000 in nearly 2015 cost 3 years before? So again, this is present value because they're giving me how much that's going to be worth, or why that item was worth $1,000 3 years before. So on this one, I'm going to treat future value. It's going to be 1,000. Present value, it's going to be, that's what I'm looking. My rate was 0.0172. Time was 3 years. And this is compounded average annually. So it's like that. So then we have 1,000 equals present value 1 plus 0.0172 over 1 times 3. We get that into the calculator. We have that 0.0172 divided by 1 plus 1 to the power of 3, and then 1,000 divided by what we got before. That would be 950.13. And as promised before, if you want to use all the formulas, by all means, here they are. I'm going to wait a couple of seconds so you can have a chance to hit a pause and copy them if you wish.